Day 50, Honors Physics, Conservation of Momentum, Problem 25. Here we have one ball hitting another ball. Classic conservation of momentum once again. Diagram over here on the left. The bigger ball is moving, or at least the more massive ball is moving. The momentum of the more massive moving ball is 24 kilograms meters per second. That's 3 times 8. Stationary ball has no momentum, so the total momentum, which is what's conserved, is right here, the 24 units of momentum to the right. After the collision, it tells us that the larger ball has slowed down because it hit something, basically, and its momentum now is 12 units. 3 times 4 is 12, and we know the total momentum has to be 24, so by logical deductive reasoning, what is the momentum of the little guy? Well, it has to be 12 units of momentum to the right. So I'm using P4 to represent that little guy after the collision. P4, momentum number 4, equals the mass of that ball times the velocity of that ball post-collision. So that must be a 12 to the right equals 2 times V sub 4. Once again, it's pretty simple. That's 6 meters per second to the right. As long as you have a diagram showing me all the arrows with the proper directions, you could say in the same direction as the larger ball was traveling or something like that, but this suffices for the velocity of that ball. Now, what you need to do in part B is calculate the kinetic energies of all these balls. So, before the collision, there's only one ball moving. Figure out the kinetic energy of the larger ball before the collision, so we'll call that KE1. That's the total kinetic energy before the collision. After the collision, you're going to have to add up 2. You're going to have the KE, we'll call it KE3, which is the larger ball after it hit the smaller ball, and KE4 for the smaller ball. You're going to add those up to get the total kinetic energy after collision and see how that compares to the kinetic energy before the collision. It should be smaller, can't be bigger. It's smaller because some energy would be transferred to heat. But if there's very little loss, we would say it's elastic. We'll see how much loss there is, or basically transfer into heat. Hopefully it's not a whole lot, but you'll find out.